This is going to set up our Freyer model for the word heat. This is how you can read a Freyer model. In the upper left-hand corner, you're going to get the definition. In the upper right-hand corner, you're going to see an image that represents the word's definition. And in the bottom, you're going to see examples on the left and non-examples on the right. So let's take a look at the definition for heat. The definition for heat is the transfer of energy from matter at a higher temperature to matter at a lower temperature. So let's take a look at this image to represent heat. There is a transfer of energy from the fire to the pan, which is increasing the particles in the pan, which is at a lower temperature, which is transferring temperature to the eggs, which is causing them to cook and to raise to a higher temperature. So the examples that I'm putting down for heat is going to be microwave and campfire, because they have a source of heat that typically is used to heat something else up. Something typically like food, which I know is a big concern for a lot of you, that you're always hungry. I'm also going to add into that example the idea of kinetic energy, because as the kinetic energy is increasing in both of these substances, therefore, it gets higher kinetic energy. Let's take a look at the non-examples. For the non-examples, I have put refrigerator, because a refrigerator is actually not transferring the energy from a higher temperature to a lower temperature, but what's happening is the temperatures are reaching an equilibrium, which I'm also going to add in to our words here. Because equilibrium is when the particles are evened out and there's actually no changes in energy or temperature. And the other word that I have on there as a non-example is temperature, because heat is not necessarily just temperature. Heat is something completely on its own. Something can have a very low temperature and not be heated. So let's take a look at our next word, which is temperature. And our definition for temperature is the measure of kinetic energy of the particles of a substance. The image that I'm going to use for temperature is the image of a thermometer, because that is the tool that we use to measure the kinetic energy of the particles of a substance to be able to read it in two different ways, which are the ways that we are going to look at for our examples. For my examples, which are here on the left bottom, I'm going to have Fahrenheit and Celsius, because those are two forms of measurement that are used around the world. Fahrenheit is typically what we think of temperatures in, and Celsius is typically what the rest of the world thinks of temperatures in. But we also use Celsius a lot in science class as part of the metric system. And the last example that I'm going to put in here is, again, kinetic energy. Kinetic energy is the theme that combines heat and temperature, but they are both very different, but the amount of kinetic energy that something has directly relates to the temperature. And just for those super sciencey people out there, I am adding in the idea of Kelvin, which is one other way that you can measure temperature. And the thing about the Kelvin scale, it's really only used by the scientific community, is because it has that point of absolute zero, which is where there is absolutely no particle movement. So just a little background trivia for you there. For my non-examples, absolute zero, as part of that Kelvin scale I just told you, would be an example of not temperature, because there is no particle movement going on. I also have included in here, and I'm a little uncertain about including it as a non-example, but the idea of equilibrium. Because at equilibrium, the particle movement has essentially evened out. Technically, we could probably take the temperature of most of the equilibriums that we will be looking at, but I wanted to include it as an example of where things have evened out, where the particle movement and motion has evened out. The last word that we're going to take a look at is the word calorie. And calorie is not exactly what you're going to be thinking about with calorie. When you think about calorie, you might associate it with food. And this is a little bit different since we are thinking about things in the particle world. At its essence, calorie is a way that we can measure heat. But specifically, it takes 1 calorie of heat to raise the temperature of water 1 degree Celsius. We're going to take a look at some examples of this in a second, but let's finish out our Freyer model here. If I had a bowl of already hot water, let's say that it was at 60 degrees Celsius, and I wanted it to raise to 70 degrees Celsius. How many calories would I need? Well, I couldn't figure it out just knowing that. I would actually need to know how much water I had, and we are going to take a closer look at that in a second. But in order for our image portion, we would need to know how much it needs to get to, what is its end temp, and how much we have to be able to figure out the calories. So my 2 examples are heat and energy transfer, because this learning about calories is really learning about the last step of energy transfer. And heat is really what we're looking at, because we are trying to look and see how much heat has been gained or lost in the transfer of what happens to something when it is heated or cooled. For my non-example of calorie, it is going to be temperature. It is not about measuring the temperature of something, but we are measuring the heat of something. Heat, temperature, and calorie. And really keep in mind that there are a lot of ways that they are all connected, but that they are all completely separate words that cannot be used interchangeably. And so we need to make sure that we understand those definitions. And I would strongly encourage you to set up your notes in your notebook in the Freyer model to have your vocabulary words on this side, having the definitions on the right side along with the examples. You could even, let me back up this train here, you could even have an example word over here and then state the example on this side as well as the non-examples, and then stating the non-examples on this side, because then you could use that to help you study as we get ready for a test on heat energy transfer.